I forgot to record it first hour. Already. It's just recording the board. It's not recording the games. All right. So let's get going here. Here's our plan of attack for this week. We're going to do day 2 of function stuff here. And then tomorrow we're going to kind of wrap it all up. Wednesday, review, and Thursday will be our quiz. If you come back from break, we'll do our next round of things with our last algebra backfill. But we'll deal with that next week. Okay? So let's go ahead and start off like we usually do. Let's say any questions that you might have from Friday's assignment, Carter? 4? Oh, is it probably because that U in between? Yeah, sure. So on here, which of these are the solutions on that interval? All right. So if I didn't give you that union symbol, that's what that means. That U means a union. So what does that actually do for us? If I didn't give that to you, all right, that first interval just means, okay, we've got solutions going from negative 42.5, which is a parenthesis, so that's open, over to negative 0.4, which is a bracket. So right now we have solutions, everything right there. And then what that union means is there's a bit of a break. Where's our break at? From negative 0.4 to a small break to 0.25, that's a parenthesis, and then it continues on to infinity. And all that union means is the joining of intervals. So nothing really too crazy off that, but that U means just is a union. So if you got multiple intervals like that, Carter, we usually use that U for union symbol. So we've got 2 sets of intervals here, and as long as you're in one of these 2 areas, I thought you were going to see there. One of these 2 areas, then you're fine to be a solution set. So here, that negative 1/3, I didn't highlight it because negative 1/3 is right in between that kind of dead space. That's why it's not been highlighted. Is that clear up for it, Carter? Yeah. Cool. Other questions anybody's got? 3. Pretty much the same idea now, just as long as it's in the solution zone. Anything else? Okay, make sure your name's on, throw in the basket. Get out your notes and go ahead and get your calculator out when you come back. We'll need it in a few minutes. So on number 2, letter A here, with this mapping diagram, don't overthink this. Would you think there, number A, letter A, would you think that would be considered a function? Yes or no? Yeah. What was that? I would say that's a function. So we look at those inputs. Now we got arrows coming out of those inputs, going to some specific outputs. But on each of those inputs there's only a single arrow coming out of each one going to a specific output. And on letter A, we would consider that to be a function there. Now I always have a few people that might be thinking it's not a function because of Q and R. Q and R are both going to the same output, but that's fine. The place that we said last week where functions do not happen is if, say, P was going to M and P was also going to N. That is where an input cannot go to, say, 2 different outputs. But you could have 2 different inputs going to the same output. That's fine. So this is a mapping diagram. It's pretty much just like almost like a table of values. Kind of looks like it. But what we have here is considered to be a function. Now we saw graphs on Friday, and we use our vertical line test. So with this graph, vertical line test, we drag it from left to right. And is this a function or not? So wait a second. I heard both a second ago. So is this a function or not? Yes or no? Carter, is not a function. Because what we have here is just a an infinite amount of points to make a vertical line. And if it's more than 1 point, it is not a function. And a vertical line on top of a vertical line is. Now, usually what happens here is we know lines are a linear function family. And we think of a vertical line as part of that family, like the black sheep though. It's kind of in that family, but not quite. So this one though, still not a function. Okay. All right, take number 3, walk it across quick. ABC, function yes or no. Number 3A,
Yes.
B, C. All right, now let's talk about reviewing from Friday, our domain and range. And then we're going to do the new stuff on the back. Okay, domain, one more time, domain, people. Is that my X's or Y's? Domain is the, so we want to talk about, again, left to right for the domain. So when we talk about domain, we are talking about X's left to right. You're looking for a clear starting location and a clear stopping location. And do I see a clear starting location for the X's then? No. Okay, my graph here is going down. Don't care about going down, but it's going to the left forever and ever. So where's my starting location at? Negative infinity. Infinities always get a parenthesis. So I'm reading it. I'm starting way out here at negative infinity. And as I read it from left to right, do I have a clear stopping location? Is it stopping at 4? Is it stopping at 5? 6? 100? It's never stopping. Now I'm going down, yes, but I don't care about down, but where am I going? To the right. And if it doesn't stop, it's going to infinity. Now range is the y values. Bottoms up. I like to think about floors and ceilings. Now it looks like there is kind of like a floor right here at -1. But what does that arrow tell my graph to do? Keep opening down. So I don't have a floor here. It keeps opening down. So do I have a floor at all?
No.
So where does this graph start off at? Negative infinity. So I read it down here at negative infinity, up, 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 up. Do I hit my head on a ceiling at some point?
Yep.
Where does it stop? Up here at 4. I do have a ceiling. And at that 4, is it going to be a bracket or parenthesis? Yeah, up there at 4 where it stops, it's all solid. And that graph is all solid, so it means it's a bracket. Correct. Okay, the circle graph. Left to right, the domain. What's my leftmost x value? Read them more carefully. And what's my rightmost x value? 4. Okay? And what's the 6 and 4 get? Parentheses, brackets? It's all solid all throughout, so I'm using brackets. Bottoms up. Do I have a floor?
Yes.
Do I have a ceiling?
Yes.
So -5 starts it and stops it. And parentheses or brackets. Again, we're starting this out next year in Algebra 2. They get a little bit more crazy, but really once you get the basics down on you, you'll be fine. It'll get a little wonky, but you got the basics going already. Okay, last one there. Domain, left to right. Now on this graph, this particular one, every year I got a few students that say, hey, -1, 2, 3, 4. -4 is my left. Why do you say nope? Yep, this goes, and where does it start off at? Negative infinity. And then left to right, and where does it stop at from the right? Same deal happens. It doesn't stop at 4, but that arrow keeps telling me go to the right to infinity. And bottoms up, people. Range. Do I have a floor? And what is that? Count carefully. -7, I think. Yeah, it's going horizontal there, so it is -7 of a floor. And do I have a ceiling up there? And it's at 5. And is that -7 and that 5 parentheses or brackets? All right. So as we've been working through there, if you got the gist of that, you're pretty much okay on domain and range. It doesn't really get, again, for what we're going to do, any crazier. And even in Algebra 2, there'll be a couple wonky things, but it doesn't get really much crazier than that for domain and range. All right, let's flip it. Function notation, my sophomores. It's just kind of a trip down memory lane. For my freshmen, again, it's one of these things of it depends on what your teachers did, how much they added in for it or emphasized. It just depends on that for you guys. Now, up to this point, okay, it depends, again, how much, again, your teachers might have did for you in 8th grade. You guys have grown up with equations reading more like y equals, like mx plus b. And at some point, right around Algebra 1, we make the transition of using what we call function notation, f of x, g of x. Now, up here I have 4 functions. And with these 4 functions, what we want to do today is that you sort of get comfortable with these. And tomorrow, if we have time, what we're going to do is then try to do a little bit of graphing with your graphing calculator on these. But what we want to do is just get in practice evaluating these to start off with. Now, the way that we read these is we say f of x equals, and then the equation, 2x plus 1. G of x equals x squared minus 1. Here, we want to evaluate, and we read this as f of 1. You've been doing evaluations since like 4th, 5th grade. It says evaluate x plus 3 when x is 2. We've done evaluations for years. So we want to evaluate f of 1. Make sure you choose the right function to work with. It clearly says f of 1. So choose the f of x function. And whatever number's in parentheses is going to replace x. So when we say f of 1, replace x as 1. And you don't need your calculator yet, because you all know what 2 times 1 is, plus 1. And what you're doing is finding an ordered pair. When x is 1, the y value is 3. And you're creating an ordered pair. Last week I said about 6th grade you learn about an input-output machine. And this is the same thing. This is exactly the same thing. When the input is 1, the output is 3. When the x is 1, the y is 3. When the domain is 1, the range is 3. All the different ways we can say that. All right, letter B. G of 1. Choose the correct function. G of x. 1 squared minus 1. 1 minus 1 is? So when the input is 1, the output is 0. When the x is 1, the y is 0. When the domain is 1, the y is 0. Take letter C now real quick. Plug in -1. All right. Choose the same function. Plug in -1 really quick. So we're going to make sure we're using these same correct functions here. Okay. Now on this one, again, don't just wait on me to this one because I do want to make sure you are doing this one correctly. It goes right back to the beginning of the school year, and throughout this school year, I keep giving you those radicals with the Pythagorean theorem. If you're not doing the mental math or your calculator correctly, you're not going to get the right number here. So, g of -1. You better make sure you're putting that in parentheses. You're not doing the mental math right, or put in that in parentheses right, you're getting negative 2. James, is that what you got? Ah, that's why I had you do it. Okay? You should be getting 0. Okay? Because what you want either your brain to do or your calculator to do is take -1 times -1. If you're doing it correctly with your parentheses, it's the same thing I told you about the radical work. If you don't put those radicals in parentheses, calculators is only as good as the operator. You should be getting 0 then. And if you did not, you got -2. Sounds legit, but it ain't. Okay? Again, you get that order pair. Now, before we move on to the next row, let's talk about those two functions that we just we looked at. The f of x function gets a specific name. What part of the family is that? We've seen a couple families we talked about throughout the years. 2x plus 1 is part of my linear function family. You should know based off the equation what family it goes with. You should know what graphs it is associated with. A linear function is just a line, right? It increases, it decreases, or it's horizontal. How about the g of x, x squared? What type of graph or what type of family is that associated with? That is my x squared is the key. It is a quadratic. Now, over the last couple of days, now we haven't done a lot of it throughout the school year. We just don't have the time to teach you everything that you didn't get in Algebra 1. The quadratic has a specific graph it goes with, and that's my U-shaped graph we pointed out to you. Either opens up or opens down. That's my quadratic. Those three things, again, I want you to kind of go hand in hand with. You see x squared, you think of quadratic, you should think of the U. You see a U-shaped graph, you should know it's quadratic, you should think of x squared. You're going down, James. Okay, let's come around, let's do the next row. H of -1. Make sure you take the right function, plug in -1 for x. And what's 1 divided by -1? Again, you just created an ordered pair, -1, -1. Who cares if there's two functions using in there? You can do operations with functions. Just make sure you use the right one. J of 49. J of 49 steals the J of x function. Square root of 49 plus f of 3. 2 times 3 plus 1. Do your order of operations. What's the J of 49 give me? 2 times 3 plus 1. And what's 7 plus 7? That's it. Now, you don't necessarily create an order pair here because you get two different functions happening. You just add them together. But don't overthink that. You're all smart enough, because no one was rattling that off. Add them together and we get 14. Okay, f of a half. Go back. F of x function says, just read carefully. F of a half says f of x function, what's 2 times a half? Plus 1. Yep, you all can do that in your head. 1 plus 1 is 2. Again, technically, we're creating an ordered pair. 1/2, 2. Now, who cares if they throw in a variable, a letter with the input 2a? Go to the right function, f of x. 2a times 2. 2 times 2a. What is 2 times 2a? And can you do anything with 4a plus 1? Are those like terms? So leave it as is. In Algebra 2 next year, you'll go that next step and work with a bit more involved ones. But don't forget about everything you learned at 5th and 6th grade with like terms, distributive property. Okay, you can't combine a 4a plus 1, so leave it as is. Last one there, j of 144. It says j of x, so the square root of 144 is. Again, one more time, you've created an ordered pair here, 144, 12. Now let's come back around and talk about the two functions I've skipped over with you. Now these two are absolutely the heart of math. All right, algebra 1, algebra 2. Linear is algebra 1. G of x is like the bridge between algebra 1 and algebra 2. And then the other two, this is another one, and the algebra 1, beginnings of algebra 2. We saw that on Friday. Heck, it's right in the function itself. It's the square root function. I showed you the graphs of those on Friday. It looks like that. It can look a couple different ways, but if you see it kind of like a curved line like that, taken off in one direction, that's a square root graph. And then the other one, we call that, we don't get into it all in algebra 1. It's an algebra 2 topic. It's called the reciprocal function. Why do we call it the reciprocal function? Because of x, and we flip it. 1 over x. That's what we call it, the reciprocal function. The graph that is funky. It gets funky. We're not going to even mention it. All right? The reciprocal function is just funky. That's algebra 2. All right. Now let's come back around and talk about the next group of problems. Because the next group of problems is always trips everybody up. You're like, A through H, that's not too difficult. I can do that. But then the next group of problems, I on, that's where the issues happen. First thing is, you hopefully realize I haven't written the same way. Okay? We're plugging in x, finding y. On I now, we don't know what x is. We know what y is. I want to know, hey, what does x have to be in order to find y? So, what we need to do on these here is, again, what is x in order to get that specific y? What we did up here, we knew x was 1, so what was y turning out to be? Y turned out to be what? 3 on this case. So what we want to know here is, what does x have to be in order to get 9? What you're going to be doing now is setting up equations. So 2x plus 1, what does that x have to be in order to get 9? You're going to have to set up equations now and solve them out. But I have so many kids throughout this time not read carefully. Like, this was so darn easy. I'm just going to take 9, 2 times 9 plus 1. 2 times 9 is 18, 18 plus 1 is 19, and I'm done. And that's not the case. Because does that say x is 9? No. It says f of x equals 9. And I know it sounds darn similar, but it's not. So use our equation skills to solve these out now. Nolan said subtract 1, divide by 2, and x is 4. So in order to get that 9, x had to be 4. 4 comma 9 is what's happening. 2 times 4 plus 1 gets you that specific 9. So to get that specific y of 9, what did you have to have for input? Only 4 works. On J, again, look at the writing of it. Just look how it's set up. It's not the same. What does x have to be in order to get a negative 9? You're setting up equations and using your equation skills. Subtract that 1 and divide that by 2. X equals negative 5. Again, you're creating an ordered pair. You're just working it backwards. X turned out to be negative 5 in order to get that negative 9. Okay? Read carefully on those. This is the one, done it for many years. This is the part that's so inconsistent. Top part's fine. It's that inconsistency on that bottom part. Next one here, g of x. Read carefully. It says g of x. So what does the equation look like? X squared minus 1?
Yeah.
Now it's a quadratic. Let's think now. Quadratics, we have two ways to solve. Square roots and factoring. We're not going to factor this one. We're going to solve this by square roots. Add one and square root it. Go back to the beginning of the year. So x squared equals 16, and the square root of 16 is? Square root of 16 is? Square root of 16 is? No, I'm not stuck in a loop here. I heard you the first 3 times. It's not 4. It's plus or minus.
Oh.
It's quadratic. How many solutions do we typically get? 2. As you guys leave me here, 35 is the magic number. You roll into algebra next year, you better remember you typically get 2 solutions. In geometry, do we usually care about the negative solution? No. Next year in algebra, we typically care about the positive and a negative solution. I know I'm kind of being an ass there, but I know, I'm aware. Okay? But you do want to keep in mind, you have to keep those 2 solutions in mind. Now, when you'll start tossing them is when you roll into applications with those, but 2 solutions to be where you're at. And what you do then is you don't create one order pair, you create, and the reason why you're creating 2 order pairs here is with that graph as well, it's a U-shaped graph, right? So on that U-shaped graph, negative 415, 415, on that U-shaped graph, go back to what we also talked about at some point this school year with symmetry. In that symmetry, axis of symmetry, we can fold it right down along that line of axis of symmetry. That's where that negative 415 and that 415 are on that axis of symmetry there, creates that U part of it. And that's why we say you get how many solutions? You typically get 2 solutions. Okay? The one time that you don't get 2 solutions is right here. That's the one time you're not getting a second solution. You're getting 1 solution. All right, last one there, 48, g of x. So now that I was an idiot on that last one. Thank you, James. Plus or minus 7. And again, you don't need to write out the order pairs. I'm just trying to reinforce to you on that. I want to see the plus or minus 7, plus or minus 4. Okay, but that's again what's happening there. All right, let's finish this off today. I copy pasted those same questions on down to this last part, but I did not give you the equations here for the functions. What I did was replace the equations with graphs. Cough it up. All right, I replaced the equations with graphs. Same questions. I want to know what's f of 0. So when we say f of 0, that means when x is 0, what's the y value? All right. So again, when x is 0, I can't plug it into an equation. I don't know what the equation is. So when x is 0, go to the x-axis. Remember, up there we created a whole bunch of order pairs. I want to go find that order pair on that specific graph. This one says, hey, go use the f of x function. So go find the order pair. When x is 0, go use the f of x function. X is 0, here's the graph. And what's that order pair's location? 0, comma 4. The y value is 4. Now, what graph do I have here? What are you doing, Carter? Carter, just stop. That is a V-shaped graph. We've talked about those V-shapes before. That is my absolute value function. All right. My sophomores should be familiar with that. It's just like the quadratic, except it's V-shaped. My freshmen are doing that right now. They did very well with that quiz. Okay, same question, letter B. f of negative 4. So when x is negative 4, go to the x-axis, negative 4, go find the f of x graph, right there, and what is that location? Negative 4, comma, 4. F of negative 2. X is negative 2, go find the graph. What's that location? Negative 2, comma, 2. I want the y value, correct. That's it. One more time now. That these were opposites. It's because of the absolute value and it's because of the specific function I graphed on that. There definitely is happening in there because of the absolute value and because of the graph I made on that one. Yes. All right, last one there, letter D. Says go do g of negative 1. So let's go use the g of x graph. X is negative 1. We want to use this one. So what's that right there? Negative 1, comma, 1. There we go. All right, last one here. Again, this last group is usually the one that's most missed. Okay? Because you have to do the same thing as we set up above. You want to find the input given the output. You want to find the x given the y. So you go and train your eyes on the y-axis first. So when y is 2, what's the x value? So when y is 2, y-axis at 2, where's my graph at? Correct. I'm right here at x equals negative 2. This is the one that students have the most trouble with. I know why, but it's all about practicing it, and more practice. Letter F. When y is 4, that's what it says. When y is 4, what is x? Go y-axis at 4. And what's the x value? X equals 0 and x equals, Deja says, also negative 4. I've got two possibilities here. Because typically, how many solutions do we get on quadratics and absolute values? 2, because this b, gentlemen, and x equals negative 4. That's, again, the troubles that happen. I don't expect you to have that mastered 100% completion on these, because those are trip-ups that are going to happen. Next year will be better. Last one, change your view. We're going to the g of x. When y is 1, what is my x value? X is negative 1, negative 3, negative 5, 2, 4, 10, negative 10, or what? Infinite, negative, positive, or we could also say all real numbers. I heard infinite, or what we then say is all. That one gets funky. I'm not going to probably ask you about that one, but all real numbers is what we say. Okay? We're going to practice more on that tomorrow.